Okay, we're going to talk about real numbers. I mean, how hard can that be, right? If you ever notice in math books, you see that word real splashed all over the books, okay? And that's to distinguish real numbers from what's called imaginary numbers. Okay, we're not going to go into imaginary numbers in this course, or in this review, but if you ever try to take the square root, which I know we haven't talked about, but of a negative number, okay, like -1, it's not a real number. Your calculator will give you an error. In fact, let's see what this one does. And this one is a little different. In order to put a negative in there, 1, hit the plus minus button, turns it into a -1, and then we're going to hit shift and square root. I get E for error, okay? Whoop, 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 error message. It takes us into the world of imaginary numbers, which is represented by the letter I. So if you've ever had algebra and went into that world before, that's fine. But we're not going to go there, okay? So that's why you see this word real all over, okay? We're going to talk about just adding, subtracting, multiplying, dividing, good old regular numbers, except now we're going to also look at negative numbers. All right, so if we review a number line, okay, 0 is, of course, in the middle. Positive to the right, right? Negative to the left. Okay, how far does a number line go? It goes forever, okay, which we call infinity, which is a figure 8 on its side. There's positive infinity. There's negative infinity. Okay, it goes forever. All right, so if we're adding numbers together with the number line, adding's pretty easy because you can think up and down the number line. If I'm adding a positive number, I'm going to go to the right. If I'm adding a negative number, I'm going to go to the left. Okay, so let's start out with an easy one. 2 plus 3, okay? Well, I'm going to go to 2, and then I'm going to add 3 more, all positive to the right. Of course, we get a 5. Okay, but what if I want to add 2 plus -3? Okay, now let me just interject a side comment here. It's poor procedure to have 2 signs side by side here. So if I wrote it like that, 2 plus -3, it's frowned upon. Okay, now the review book I used for the practice exams, I think does that. And forgive me for not being 100%. When I record, I'm re-recording these videos, I think I mentioned. So when I recorded it the first time, I kind of remember myself making that comment. But I didn't look closely this time. But I'm pretty sure your book does that, or your book, or the book that they gave me to prepare for this course. That's really frowned upon. Okay, so we want to put the parentheses, but normally we associate parentheses with multiplication, right? There's no multiplication going on. Now, 2 parentheses -3, we'll get to this. That is a process of multiplication, 2 times -3. But this one is not. This is 2 plus -3. So the only purpose of that parentheses is to separate the plus sign from the negative sign, right? So I don't want to confuse anyone with that, but I want to make sure we're clear. Okay, we'll talk about multiplication later. Let's add 2 plus -3. You can think up and down the number line if you're adding. Okay, it's a negative number, yes, but we're adding. 2 to the right, 3 to the left. That's -1. Okay, think up and down the number line. I went 2 to the right and 3 to the left, and I got -1. Now, what if it was -2 plus 3? Well, now I'm going to go 2 to the left and then 3 to the right. I'm going to get a +1. Okay, so when you think up and down the old number line, when you're adding, it's pretty easy. How about 3 plus a -5? Well, I'm going to go 3 to the right, but then I'm going to go 5 to the left, and that'll give me a -2. How about 2 negative numbers being added? How about -3 plus -4? Well, I'm going to go 3 to the left, but then I'm going to go 4 more places to the left. I didn't write it down, but you can see where I'm going. -7. Okay, so it's easy to think up and down that old number line when I have an addition problem. Okay, I just positive numbers to the right, negative numbers to the left. I'm probably swaying the opposite direction that I'm talking right now because you're looking at me the other way, I bet you. But trust me, I'm going to the right now and I'm going to the left now. All right, All good? It's like easy if you think number line. Now, we don't always want to think number line. You're not always going to draw a number line, right? So we have to learn the rules regardless of this number line, but it's easy to think up and down that number line when it's a nice visual for you. Okay, well, what do we do in other circumstances? Well, it depends. Okay, two positive numbers, we got that down, right? No problem. What about two negative numbers? Well, so this goes for either both positive or both negative. Okay, so if I want to add two numbers with the same sign, okay, it's like a procedure here. It's not hard. They make it look like a procedure. I'm going to add the absolute values. Okay. The sum, remember, sum means the adding, so the answer that I get will have the same sign, okay, as the numbers I was adding. So we haven't really talked absolute value, so let's take a minute to talk about that. Absolute value just says how far away from zero am I? Okay, how many steps away? I don't care what direction. That's the mistake people sometimes make. I got zero here, 1, 2, 3, -1, -2. I just want direction. How many steps? I mean, I don't want direction. How many steps? Absolute value is showing like these vertical bars in here. And I put the number inside. That's asking, what is the absolute value of 2? So that question says, how many steps away from 0 is the number 2? 1 step, 2 steps. Okay. The absolute value of -2 asks the same question. How many steps away from 0? I don't care which direction. Go to 0, walk to -2, and tell me how many steps you walk. You walk 2 steps, right? So an absolute value wipes out the sign of anything inside it. It just wants to know distance away from 0. So our procedure here says add if we both have the same sign. Okay, so they're going to both be positive, which is the no-brainer case, or both be negative. I'm going to get the absolute value, so I'm going to ignore the fact they're both negative. I'm just going to add the numbers together, and then the answer is going to be negative. Okay, so that's pretty easy. -6 plus -4, they're both negative, so I'm just going to forget about it. 6 plus 4 is 10, but then the answer, the sum, has to be the same sign as the other ones. Okay, this only applies when they're the same sign. -8 plus -6. They're both negative. 8 plus 6 is 14, so -14. Okay. -1 plus -9. They're both negative. 1 plus 9 is 10. -10. Okay. You add the absolute values and you keep the negative sign because they're both negative. Okay. Obviously, if they're both positive, we don't need any help there, right? Like that's easy. We don't need any help with the other ones with the calculator, of course, but I just want to review these rules. This calculator is a little goofy with its negatives. Goofy from my world of using mostly Texas Instruments, okay? Maybe you use these calculators all the time and you're more used to it than I. But for me, it's a little odd because you have to put the negatives in a little different, okay? So for this calculator, if I wanted to do -7 plus -11, okay? I got to go 7 and then hit the plus minus button, which makes it -7. Can you see that okay? I have a light, but the light seems to cause more glare than anything. So this button here is a plus minus button. So 7 negative, okay, plus 11 negative. So plus 11, but then make it a negative by hitting that button, equals -18. Add the two numbers. 7 and 11 is 18. Keep it negative because they were both negative from the start. Okay, let's do one more with the calculator. -5 plus -2. This one 5, make it a -5 plus 2, make it a -2 equals -7. Okay, all good. But if we had to do like a decimal or a fraction, well, I mean, if it's a fraction, you know, -3/4 plus -1/2, common denominator, blah, 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 all that rigmarole we talked about in an earlier video, or 3 fraction button 4, making a -4, plus 1 fraction button 2, making a -1/2, equals -1 1/4. Okay, which is -5/4 if we go with typical fraction. All right, all good there? So that's adding numbers with the same sign. Well, what if we have to add numbers with opposite signs? And let me really underline add. We're still adding, but here's what you do. You subtract the absolute values. Huh? It's an addition problem, but we're going to subtract. We're going to subtract the absolute values. Okay, then we call still a sum. Okay, so we're adding here. The sum is let me reword that. The sign is the same sign as the number with the larger absolute value. Huh? What does that mean? All right, let's do one, huh? Let's take -5 plus 7. One's positive and one's negative, and I'm adding them together, right? The instructions say subtract the absolute value. So ignore the signs for a minute, subtract the two numbers. 7 minus 5 is 2. But now I've got to make a decision on whether or not it's a +2 or a -2. And that's made here. The sign is the same as the number with the larger absolute value. I call it the battle of the signs. Who wins the battle of the signs? 7 is bigger than 5. 7 is positive. Answer is positive. Okay, so whoever's bigger wins. Okay, but I actually subtracted in this problem, which is an addition problem, but I subtracted. How about this? -13 plus 4. One's positive, one's negative. I'm adding, and that's crucial. When we start subtracting, we got to think differently. So I really subtract, though, even though I'm adding. 13 minus 4 gives me a 9, and I got to see who wins the battle of the signs. Well, 13 is bigger. 13 is negative. Answer is negative. Okay. How about -3/4 plus 1/2? Okay, maybe we jump to the calculator for this one, right? 3 fraction button fourths, make it a negative, plus 1 fraction button half equals -1/4. Okay, so we're gonna subtract absolute values. I'm sorry, give a thumbs up. As I'm recording this video for you, I'm giving a final exam in another class all over Zoom. So I just waved at a student who was signing off. So sorry about that. Anyway, I'll look back and laugh at these videos at some point, or you will. Okay, so we good there though? I'm adding, that's crucial, but one is positive and one is negative, so I'm really subtracting absolute values, and then I see who wins the battle of the signs. Okay, let's throw that into some algebra. Let's do a little algebra here. Yeah, I like it. How about negative 11x plus 7x. Now I'm combining like terms again, but one's positive and one's negative. So I'm really going to subtract the 11 and the 7 and get a 4x. And who wins the battle of the signs? 11 wins. 11's negative. Answer's negative. Okay. 7y plus negative 12z plus negative 9y plus 15z. Okay, now let's be cautious here. I've got negative signs, that's true, but it's all addition, and I like to really make those addition signs bold so we can see it. It's still an addition problem, okay? A lot of times the word negative and the word minus or the word subtract are kind of all intertwined and interchanged. And I could see how that happens, but they're really not the same, but yeah, you could argue they are the same. But here we don't have a subtraction problem, we have an addition problem. It just so happens I have negative numbers in the mix, but it's still addition. So why does that matter? Well, remember the commutative and associative properties, they only work for addition and multiplication. So I can jumble this up, mix it up any way I feel like it because it's an addition problem. Okay, so again, we typically won't do this, but I can physically put the y's together just so I feel a little better. And I can physically put the z's together just so I feel a little better and I can see it a little clearer. Okay, I do it mentally, but you're of course welcome to physically do it. And you can do it because of the plus signs. If these were minus signs, I could not just do the little maneuver I did there. Okay, now it's kind of clearer though. I've got a 7y plus a negative 9z. One's positive, one's negative. I'm really going to subtract, or excuse me, I said z, I meant y. I'm really going to subtract and get a 2y, but who wins the battle of the signs? Negative wins. So negative 2y plus, what's cooking here? A negative 12z and a positive 15z. I'm going to really subtract and get a 3z, and it's going to be positive. So there we go. Negative 2y plus 3z. Okay, everybody cool with that one? Let's throw a distributing property into the mix there. How about this one? I'm going to distribute and get a 21x plus 24, but then I have plus negative 25x. Okay, let's not physically shuffle this one. Let's just mentally do it. I'm going to add a 21x and a negative 25x together. One's positive, one's negative. So I'm really subtracting to get a negative 4x. 25 wins the battle of the signs, so negative 4x plus 24. Okay. Everybody good there? I think that's pretty good. Let me see here. We're going to subtract. Yeah, you know what? Let's do subtraction. I don't know how long this video is. One downfall of the way I'm recording now versus how I did it before was that I don't have a timer to show me how long these videos are. And I don't want to make them too long to make them too excruciating for you, but I think we can sneak subtraction into the mix. Subtracting real numbers. Okay, subtraction can be thought of as adding, huh? Yeah, adding. Adding the opposite. Subtraction can be thought of as an addition. Adding the opposite. Okay. Well, if I take, good old 8 minus 3, I know that that's good old 5. I don't need my math review class to tell me that. Okay. But what is 8 plus negative 3? What is that? Well, it's also 5, right? One's positive, one's negative, so I really subtract and get a 5, and 8 wins the old battle of the signs. It's a 5. Okay, so, compare these two here. In one circumstance, I've got minus positive 3, and in the other circumstance, I've got plus negative 3. Okay, so subtraction can be thought of as adding the opposite. That's a minus positive 3. I can call it plus negative 3 instead. The first number stays the same. Second number can be thought of as adding the opposite. Okay, now when I teach this, I go through examples where we do just that. We do this little procedure. But then I try to push students away from it, quite honestly. Okay, and I'll kind of explain why. 7 minus 10 is really 7 plus negative 10. So now I know my rules of addition. There are two numbers, one's positive, one's negative, so subtract them and get a 3. But who wins the battle of the sign? 10 wins, so it's negative 3. Okay. How about this one? 5 minus negative 6. Oh, baby. Minus negative looks bad, but it's really our best friend. Why? Because I'm going to change the minus to a plus, and I'm going to change this number to its opposite. It was negative, now it's positive. Now it's just good old 5 plus 6. So minus negative is plus positive. It's really our best friend. It's easy. Looks bad, but it's easy. All right? Now, the first number may be negative, so we may still be kind of screwed, if you will, there. The first number never changes, but minus negative becomes plus positive. That makes it a little easier. So now I've got a positive and a negative. I'm adding, which means subtract to get a 6. Battle of the signs is negative 6. Okay, yes, we can do all this on our calculator. We can do this one here, 5 minus 6, make it a negative 6. We're going to get a positive 11. Okay. 9, make it a negative 9, minus 3, make it a negative 3. We're going to get a negative 6. Okay. All right, so it can be done, with the calculator, but I like to make sure we have these rules nailed by hand also. Fraction though, time is of the essence, of course. If we had a kind of a messy looking fraction of negative 3/4 minus 2/3. Well, what do we got? 3 fraction button fourths, make it a negative. Now I didn't make the change here, so I won't make it in the middle of the problem. So now it's a subtraction problem, and that's now a positive number, right? 2 fraction button 3 equals. It's negative 1 and 5/12. Everybody see this one? This time I didn't make the change. I just, because I'm letting the calculator do the work for me. But the change would have been, hey, leave this first fraction alone. Change that minus to plus, but now the second fraction becomes a negative. Let me just do it that way. 3/4, make it a negative. Now I'm going to hit the plus sign. 2 fraction button thirds, but I got to make it a negative. And you see I get the same answer. Okay. Again, the procedure, if you will, is to go ahead and make these changes. Change the minus to adding the opposite, but I try to push students away from it because it's kind of cumbersome to do it. I like to, what I call, do the mental switch. Okay, what if we got a bunch of problems here? What if we have 7 minus negative 5, minus 11, minus negative 6, minus 19? Okay, the book's going to say, or the instructor might say, we're going to change all those subtractions to add the opposite. That number stays. This becomes plus. That becomes its opposite, which is positive 5. This becomes plus. That becomes its opposite, which is negative 11. This becomes plus. That becomes its opposite, which is positive 6. This becomes plus. That becomes its opposite, which is negative 9. Okay, I just changed every subtraction. With the whole problem was subtraction, right? Now the whole problem is addition. How does that help me? Well, I can think up and down the number line. I could sit here and say, go 7 to the right, go 5 more to the right, go 11 to the left, go 6 to the right, go 19 to the left, and I could think my way through it like that. Okay, or the commutative property, now that it's addition, I could group things together. And some books are going to actually physically write the 7 and the 5 and the 6 kind of all side by side. They might even like stick it in a bracket or something just to say, hey, these guys go together, and then we'll put another bracket here, and these guys go together. Okay, so now we got everybody kind of segregated there based on their sign. So this is a real no-brainer, right? 7 plus 5 plus 6, all positive. I don't have to think about it. Okay. This is a equally no-brainer because a negative plus a negative, you just add them together and it's still negative, so you don't have to think too hard about it. Here's the only time where you might have to stop and say, wait a minute, what was the rule again? One's positive and one's negative, so I'm really going to subtract and get a 12. And then I got to do the old battle of the signs and make it a negative 12. Okay, so, you know, there's merit to this, but it's time consuming and it takes a lot of effort. And it's certainly on the exam, it's very time consuming. Okay, but even by hand, you know, what I would do if I were when I teach stuff like this, I always say, you know what, the minus negatives, they look so bad, but they're actually so nice. A minus negative is a plus positive, right? So I only change those. Change the minus negative to plus positive. Leave the others alone. Okay, so you see what I did versus what we did the first time. First time we changed them all. This time I only got rid of the minus negatives. I leave everything else alone. And now to me, it's a mental game. It's, hey, and I just like to work through it. 7 plus 5 is 12. You know, I'll just do maybe one step at a time. Okay, 12 minus 11, I don't even have to think anything special there because it's a big number minus a small number. I got that figured out. Okay, 7. So here one time I got to think, you know, 7 minus 19, which really means 7 plus negative 19. So I can think 7 to the right and 19 to the left. I can really subtract them and, you know, I can follow my rules. But in my mind, that's a negative 19. Even though it's not a negative 19, right? This is 7. This is positive 7 minus, to spell it out, positive 19, right? That's what it says. But that's not what I see. What do I see? I see a positive 7 and I see a negative 19, and I'm going to add them together. That's not what it says, but that's what I see, because I know I can leave the 7 alone. I can change the minus to plus, and I can change that to a negative 19. It's easier to add, right, than it is to subtract. So I'm just going to add a 7 and add a negative 19 together in my mind, and I'm going to get a negative 12 when I do that. Okay, so that's how I would tackle this one by hand if I were tackling it. Okay, what about the good old calculator? Time is money there. Time is everything on the exam. 7, let's put it in just like it was stated. Minus, okay, 5, make it a negative 5. Minus 11, minus 6, make it a negative 6. Minus 19 equals negative 12. We got it. We just got to be careful on this little calculator when we get a big old string of commands, because this calculator doesn't know all the rules. So we got to be careful. This was nothing but additions and subtractions, so it's okay. But if we had a bigger problem that involved subtraction, addition, multiplication, and division, and maybe exponents and all kinds of stuff, which we'll get to, I would never plug it in this little guy. I mean, I would never plug it in even a bigger calculator, but I'd feel more confident plugging it in a bigger one. But I'd never feel confident plugging it in that one. Okay, so I bet you we're real long on time. Just let me throw one in with the XYZs here. Negative 4x minus 9y minus 2x plus 12y. Again, I personally, but I've got a lot of experience doing this, I don't rewrite it unless it's minus negative, because in my mind, it's already an addition problem. And that's a negative 9 and a negative 2. I'm not going to physically show it as plus negative 9 and plus negative 2. That's just the way I see it. It's a negative 4x and a negative 2x I'm going to put together and give me a negative 6x. And it's a negative 9y and a positive 12y that I'm going to put together and give myself a positive 3y. Done. Okay, so practice it if it's concerning to you. But again, it's calculator and something like this, obviously you can't put the x's and y's in the calculator, but that regular number you can. All right, I'm going to definitely call it quits now. And we will pick up with multiplying and dividing these numbers in our next video.